Okay.
All right. Hello everyone, and today we'll be having the new chapter. So, any concern with the exams and so on and so forth. Okay. So, again, that degree it's literally available on Blackboard, and there was a couple of people that I haven't really checked the email. If you submit the exam by email, I check a time, and it works, and it usually take me a little longer to get it done. So, I do apologize for that. Okay, so yeah, so that's pretty much a thing that we have to take care of. Okay, so any concern, any question that you want to any any problem with the third exam? So yeah, so again, that the third exam we have like different version. So the questions might not be the same for each question, so you gotta be really careful with that. Okay, so it's really important that we're gonna focus on the exams and then do all the homework problem. And then if you have missed anything, you can also watch the video on Blackboard. I believe those are really important. Okay, so you can watch it again and you can read the notes if you miss any of them.
Where can we find the grade you said, Professor?
We go to the so you go to the tools, right? And then you're gonna click on the grade, my grade. Again, if you submit work on Blackboard, let me just repeat that again. If you submit work on Blackboard, you're gonna get your grade. If you don't submit work on Blackboard, then you will not be able to get the grade for that. Okay, so you will have to wait for a little bit. I also received some concerns saying that I got some Ethernet uh, connections, problem. You have to let me know and tell me about the issues are, and then I might let you take a second exam and count twice. Um, so whatever you get on the second exam will be the grade that you can receive in the third exam. So, but for those of you who took the third exam, so this is 20%, and it's really important. So you're gonna go to the tour, and then you get on the my grade. Did you file your grade in Blackboard? Okay, so if you can file your grade in Blackboard, so that would be fantastic. All right, that would be really good. And if you can't file your grade in Blackboard, you might have to go to the office hour for today. And
So
then
you haven't submitted yet, Professor?
did I submit it?
No, not even exam 1 or 2. It don't even show up. Like exam 2, it don't even show up.
No, the third exam. So to submit for the third exam, great. It should be there. What's your name?
Oliver? Yeah,
Oh,
it's not there.
it should be there. You double check that later on. But if you submit work, it should be there. If you haven't submit work, it might take a little longer. And I do apologize because it usually takes like 3 or 4 minutes to download one or two images from the file. If we convert them into a single PDF file, that's gonna make my work a lot easier by using a certain programs, a certain like file like that we have. We can actually use like Genius Scan is actually really cool, and you can scan all of the images as one, or you can use the Adobe Scan. Um, Adobe Scan, I believe it's also another scan which is free for us, and then you can scan your work and upload it. That's gonna take that's gonna help me a lot when I grade the exam, so I can get the grade a lot earlier. Okay, so anyhow, any concern, like any questions about the first, again, all the videos uploaded, and make sure that we watch the videos, and whenever you need help for that, I feel like that's really important to have those. Okay. I will be posting the video 19 and 21st on Blackboard for today. So it's watching the video is important. And after today, I will be making the link, uh, addressing the YouTube link that you can watch all the lectures, like from the earliest to the I'm sorry, from the latest to the oldest I believe that's going to be really helpful when you can see those video game, if you miss the date, for instance, or if you miss the work, that you don't understand what it is and can watch all the YouTube links, and that's going to help if you can do it. All right, so and actually post the chapter 6 summary and chapter 6 practice questions on Blackboard, and making sure that we're going to do some practice for that. So today we're going to have like a new homework, but it will be due like next Wednesday because the homework was really complicated. So I'm going to upload it soon under the homework sections. But now we're going to go to chapter 6, which is what we call the binomial distribution. So this will be the new chapter that we're going to work on. And again, that the reason why this chapter was really hard, it's not really as complicated as chapter 7, but this is the question that I consider the question that people mostly left blank on the exams and the final exam, and because it's kind of confusing. So it's not complicated as chapter 7, but it's not as hard as chapter 5. But this chapter was a little bit hard to distinguish what it is. So I really want you guys to be able to know what we're doing and utilize all of that. So this is what we call chapter 6. So what is the chapter 6? The chapter 6 is basically we want to talk about the binomial distributions, and it's really important that we have the table downloaded on Blackboard. If we don't download the table, it's very likely that we can pass the second exam. So that's really important that we're going to download it. How can we download it? It's actually on Blackboard, I think. So we can go to the informations, and I think I forgot to upload it. So it should be the formula package. So we need to have this chart on Blackboard. So that should be formula package. Okay. And then we're going to utilize this package like for the rest of the semester because it's really important to have that done. All right, so this one is formula package right there. And we're going to be using that chart to like the final exam. So make sure that we're going to stick with that. It's not there. Let me just double check that. Okay, so I do apologize for the inconvenience that is has. It should be there for some reason. Yeah, that is the file that I'm looking for. Yep. And then after so we're gonna click on a file right there, like under the informations, and then we click on the package, and this is the file that we're gonna use. Started from the second exam, we have to use the table. So you cannot pass the exam without using that.
So how we download it again, Professor? Sorry.
Again, that we have two ways of doing it. The first, that we're gonna go to Map 23, and then go to BCC on Google, and then can download it from the supplementary handouts. So that would be on the formulas and table package right there. Okay, so another way of doing it is that we're gonna go to the informations, and then we gonna have this PDF file. Okay, so we're gonna click on it, and it will be automatically downloaded to your computer. And this file is really important that we need to use it started from a second exam from chapter 6, 7, 8, and 9. Okay, so make sure that we're gonna have this table for the rest of the semester because it's really important. Okay, so I prefer people download it on Blackboard, or if you can, or you can just go to the math department website, Map 23, and then you download a chart. Make sure that you're not going to download anything else because those are pretty useless, except for the fact that we're going to have to use this table for chapter 6. So what is the binomial distributions? The binomial distribution is, of course, this is what we call the discrete model. It's really important that we can think of it. This is something that we can count the number. We call it discrete model, okay? Discrete model. And what it means by discrete model, it's countable, right? It's countable, something that we can count like 1, 0, 1, 2, up to n. That's really important that we need to understand. Okay. So, and what else? All the trials, all the cases that we took into account have to be independent trials. So each outcome going to be the same. Let's say we have like 10 chairs, so each chair going to have a same chance of happening. So we just call identically independent trial. Okay, and so identical. I would say identically independent trial. It's really important that each case is going to be the same. Okay, and I will let you know what it is by giving us like a few questions. And a very important thing that we need to understand is that there will be the number of success and the number of failure. So success versus failure. So only two cases, right? Two possible cases. This is what we call the binomial mean bi mean two, right? The tri mean three, binomial. We learned that before. So we have two possible cases, success or failure. And it's like it's really hard to think of like what it means by success, what it means by failure. It just literally means something that have to be coming up with a probability. So we call the success, and the failure will be 1 minus b. So in this scenario, it's always important that we're going to put the p in this case. So the p that we're going to use will be the probability of success, and then the failure that would be 1 minus b. Okay, so they have to add up to 100% for that part. So let's say the change that we can graduate will be, let's say, 80%. So the chance that we can graduate from the college will be 20%, for instance. Or maybe the chance that we can go to the gym this weekend will be 40%. The chance that we cannot go to the gym is 60%. So they have to be like, add up to like 100. So that's really important. We're going to read them down as the variable is 1 minus p. Okay, so it's really, really important. On the other hand, we also need to understand the certain case scenario will be the total probability of the binomial have to add up to 100% as well. I mean, meaning that each case probably is not only like the success or failure. It's obvious, but like the total when we add them up have to be exactly 1. So this is the way that we look at it and utilize that on the exams. And also very important thing that we need to pay attention besides the note that I uploaded is that we're not gonna use the probability tree. It's really complicated, but what we need to be working on will be on table number 2. So remember when it comes to chapter 6 that we have to use table number 2 will be used to find the probability. Okay, so we're not going to do like a lot of mathematical equations and so on and so forth, but we should be able to read the chart using the table that we're looking for. So that will be the chart that we have to use, table number 2. So I feel like this one is really important because if you can't box them, and we might forget it. So table 2 will be used to find the probability for this class. So anyhow, we're going to work on the questions. So this will be a pretty okay questions. So there will be the 2 format of the exams, right? So the exam format, I would say we have 2 of them. I just consider one example for that. I would say it's pretty interesting example. So one we call multiple choice questions, and what we call multiple choice question, meaning that we consider A, B, C, or D, or E, how many questions that we have on the exams, and how many possible answers for the exams. And then, so those are we call multiple choices. And then we need to be working with like multiple choice versus the short answers questions, right? So that's pretty interesting. That's pretty important up to now. Like which one would be the more interesting, short answers or multiple choice question, right? Which one do you choose? For me, I always prefer like multiple choice questions. The reason behind that because this one is very easy to do. Let's say if you get it wrong, you don't get partial credit for that. So this is the one hard thing. But I always prefer multiple choice questions. But if you just in case that if you want to get a really good grade, by on a multiple choice question without studying, that's almost impossible. Even if that you're really good at guessing, but it seems to be like a little bit tough for us to actually get a really good grade on the multiple choice questions. I will let you know what happened with that. Okay, so I still prefer multiple choice method because it's easy. It's just A, B, C, D. We don't really have to write down a lot of work, but this one is pretty confusing. It's pretty hard to obtain a good grade. I will let you know what it is. So let's say we just consider a question, right? A quiz, just like a small quiz, okay? A quiz has 5 questions, 5 different questions, okay? And each question has 4 possible choices, okay? Each questions has 4 possible choices, okay? 4 choices, A, B, C, D. And assuming that we don't study at all, if we study, then we don't really have to worry too much about that. But assuming that we don't study at all, okay, we don't study, we just basically go to class and then take the exam, okay? So assume that we don't study at all. We do not study at all. And then meaning that we only take the guess. We only take a guess on each questions. On each questions. Okay, so what that means is that the only 1 possible answers out of 4, right? And then we only take a guess for that. And of course, the probability that we can get the correct answers will be equal to, what do you think? Like correct answers out of 5 questions. What is the probability that we're going to get a correct answer for each question?
Just one.
25%, right? Because we have 1 answers for each question. So out of 4 choices, so that should be 1 out of 4. Do we agree? Right? So I believe that is really important that you have to understand it that way. So the chance that we can get the correct answers is 25%. Correct? Right? Makes sense? Because we have like 1 choice out of 4. Let's say B will be the correct answer, so out of 4, so that should be 1 out of 4. Correct? So we had a thing of it. So what is the probability that we're gonna get the wrong answers? What do you think?
25 as well.
No, because we have
75.
75%. That's correct, because we have like 3 possible answers for that. So that should be 75%. So this one is the P for the correct answer. This is the P of a failure, for instance. Okay, so this is what we consider success or failure. It's not just like the question that we answer. All the cases that we consider, and each questions are going to be the same thing. So it doesn't necessarily mean that A have to be connected to B, the B have to be connected to C or D, right? So A, B, C, or D are separate questions. So now we're going to go to the probability for that, okay? So this is a thing that we want to show it how to get it done mathematically, but we're not going to spend a lot of times working on this method because it's pretty complicated to do it, the math. So let's say, what is the probability? So this is what we have to do with the probability. What is the probability that we can ace on the quiz? Okay, so we do not only want to you know only get like 1 or 2 questions, but we want to ace on the quiz. We want to get 5 correct answers. So that's easy and simple, right? So we can't take a guess for each questions. We need to make sure that all the guesses are correct for all possible answers that we have. So anyway, so we're gonna have 5 questions. We're gonna box them 5. So this is question number 1, and this is question number 2, and this is question number 3, and this is question number 4, and this is question number 5. So for instance, we have 5 different questions, and then all of them have to be the correct answers, right? Because you want to make sure that I am like the king of the guess generally, so I can guess all of that correctly. So put that this one is correct, and this one has to be correct, and this one has to be correct, and this one also has to, this also has to be the correct answers. and this also have to be the correct answers generally. Okay, so we need to have like 5 correct answers, and then we need to deal with that. So the probability that I can get the first question's answers correctly always be the same, because we can literally deal with that. The probability of getting the correct answer for any question with 25%, because we need to think of it like 4 choices and 1 choice correct, so it has to be 25. So in this case, so that will be equal to 0.25, correct? Because on the first question, the chance I can get the correct answer is 0.25. And similarly, on the second questions, the probability I can get the correct answer is also 0.25, and this one is 0.25, and this one also 0.25, and the last one also 0.25. Do we agree? Right, because each question is going to be like the same chance of getting it right. So should we multiply them or should we add them up, right? Because when you add them up, that makes no sense. It's more than 100% chance of getting of acing on the quiz, right? So remember, so in order to ace a question, we only have 25% chance of doing that. But in order to ace 2 questions, I'm sorry, in order to answer like 2 questions correctly, so the chance of doing that should be lower, right? So we cannot just add them up. You tell me that, well, that'll be 50%. You know, it's have to be lower than that. So the way that we can do it is we need to multiply everything together. So like 0.25 times 0.25 times 0.25 times 0.25. And this going to give us the answers, which is equal to what? Okay, so we're going to use the calculator to compute that. The calculator that we'll be using will be basically, I uploaded the calculator that I uploaded in Blackboard. Okay, so this one is really important. So we're going to utilize those calculators on the exams for this kind of questions. I would have to use it for every single question generally. So we're going to take 0.25 times 0.25 times 0.25 times 0.25 and times 0.25. And we're going to get the answers, which is 0.9765. If you know the fact that this one is equal to 0.25 and raised to the 6th power, and then we should be good. Okay, so we can also do that as well. So this one is 0.25 raised to the 6th power, and you should be able to get the same. I'm sorry, 5 power, because we have 5 questions. I apologize for that. So this one is 5 power, right? So when we do that, so the answer that we came up with, which is so we have 9.7 raised to the 10 to the negative 4. So that one turns out to be what? 0.000, right? So we're going to go 1, 2, 3, 976. Okay, so it's really important that we do it that way. So that would be this is 9.765 raised to the 10 to the negative 4. So when we convert to the decimal number, so that becomes 0.000976, right? And this one's not even, if I want to round them up, it's basically 0.001, okay? But that one was really, really small compared to what we're doing. So let me just type in here, so that'll be 0.001. So around that, right? I just round up a little bit. If I want to route this to percentage, it would convert that to a percentage. I just take 0.001 and then multiply by 100. I got the answers, which is 0.1%. You can see how low that is, like in order to ace in the quiz, given by like 5 questions with 4 choices on it. If you only take a guess, we only have 0.1% of answers correctly, okay? So now we're gonna go to any concerns, any question for that? So we're gonna go to like part B, for instance. I don't want you to be greedy. I don't want to answer like 4 questions correctly. I'm sorry, 5 questions correctly. I just need 4. I just want to pass like with a B. and let's see what it is, right? And we take the multiple choice, and we can literally see that the chains were pretty low. And I will basically prove it to you guys right now. So instead of we acing on the quiz, now we just need to figure out a probability that we can't answer 4 out of 5 correctly. Okay, answers like 4 out of 5 correct answers, right? Correctly. Okay, so this is the thing that we need to deal with. So now I consider we have still 5 questions. So 1, 2, 3, 4, and 5 right there. Okay, so let's say the same thing for this. Now let me just redraw the circle. It doesn't look like a circle. So this is like second question for that. So let me just redraw them and see what's going on with that. So I need 4 correct answers, right, instead of 5. So what's going on with that? Anyone? Okay.
So four will be correct and one will be wrong.
Yeah.
So it'll be 0.25 for 4 of them and 0.75 for one of them.
That's correct. So 0.75, maybe on the first question. I don't know. It can be on the first questions. It can be on the second questions, or it can be on the third questions, or the fifth question. So just assuming that it's on the first question. So this is taking the order for that, right? So that 0.2, 0.75, 0.25, 0.25, and 0.25 for all of that. Okay, so it makes sense because we need 1 wrong and 4 correct. So the wrong question will be on this, correct? So this one is wrong, this one is correct, and this one is correct, and this one is correct, and this one is correct. So we learn from the binomial. So the wrong questions can be on the first, can be on the second, can be on the third, can be on the fourth, can be on the fifth, but they have to be the same. Like all of these percentages have to be the same because we need 4 correct and 1 wrong. So this one is basically the combinations of C, and then we 5 pick 1 or 5 pick 4. It doesn't matter. In this case, that we're going to have 5 questions, and I pick 1 wrong answers. This will be the same as 5 questions. We pick 4 correct answers. So it's going to be the same thing for sure. And then we want to multiply all of that together. So let's say this one is 7.75 times 0.25 times 0.25 times 0.25. So in this scenario, 5 pick 1. So 5 pick 1 is basically 5 different answers, 5 different possible arrangement for the wrong answer. So the wrong can be in the first, second, third, fourth, and fifth. So in this scenario, we're gonna get 5, and then we multiply by 0.75, right? So that's really important because we're gonna get 1 wrong and 4 correct. So times 0.25 raised to the 4 power. Okay, so I feel like it makes sense, and it's actually it should be higher than that. You forgot to multiply by 5, so we're gonna take 5 times 0.75, but we need to consider the order of the wrong question. It should be slightly higher than that, times 0.25 and rate to the 4 powers, right? So when you rate to the 4 power, just take 0.25 times 0.25 times 0.25 times 0.25. I feel like that's gonna be a lot easier. And then when we do the math, yes, because we need to consider a different case scenario where we can put the wrong answers on the question. So the wrong answers can be on the first questions, can be on the second, can be on the third, fourth, and fifth. And this is that we learned from the last class, where we need to take the combination of 5 and then we pick 1. And the answer for that would be equal to 0.014, okay, 146 generally. All right, so in this scenario, I can compute the math, and then it's become 0.0146. It should be, if I round up a little bit, it should be around like 0.015, right? So I just round up a little bit, just want to make sure that my numbers round up to 3 decimal number. right? And then 3 decimal a little bit better, and I want to box them. All right. So in order to answer like 5 correct, we have like 0.1%. In order to answer 4 out of 5, we have 1.5%. If we want to convert that to percentage, then so this will be 1.5. Correct. So this will be 1.5. Let me just do that. Okay, this is 1.5%. But I guarantee you that doing that is really tiring. It's not fun like to compute all of these with the combination of 5 pick 1 as well, right? And so remember that we need to multiply 5 because we have a different order for the wrong questions, and then we have 5 of them, and then we multiply. We're gonna um, have the same thing, just multiply by 5. If we have like 2 wrong and 3 correct, we're gonna have like 5 pick 2, and so on and so forth. It's going to be the same thing that we did for the combinations, and then we just multiply them. So let me just do it like indications for 0.75. This is the chance I can get 1 wrong, and also the other one is the probability that we can get 4 correct. Okay, so this one is 4 correct answers. Okay, so and of course, on the top part of it, we need like to have 5 correct answers. So this one is 5 correct answers. You rate to the 5th power. 5 correct. So it seems to be like a little bit more challenging for us because doing this math's not fun, right? So the way that we're gonna be doing on chapter 6 is literally using a table. So the table that we have to be using, we put on table 2. So I need to verify all of these values. So I can't just simply tell you that, well, this is the numbers always be correct. I need to show you the math first. And then now we can use the chart to compute all of these percentages correctly. So how we're going to use the chart, it will be the thing that we have to deal with and solve for the problem. So first of all, I need to copy and paste, right? And then we're gonna go to the thing. I'm gonna write out the question first. We just do the same thing. What is the probability that we can ace on the exams, on the quiz? I'm sorry. Right? We're gonna do the same thing for that. And then we're gonna have the n equal to 5 questions, right? And then we also have the probability of answers correctly is 0.25, I believe, right? Because we have 4 questions, and each one is we have a 25% chance of getting the correct answer for this. And I'm going to copy the chart. The chart that we have to be using will be this one, right? Table number 2. Why do I only copy this one? The reason behind that, because we only look at the n equal to 5. All right, so let me just show you what it is. Yeah, this is what the chart looks like. Okay, this is what the chart that we can see, and what's happening to that. All right, and we can see them right there. Okay. All right, so we need to identify the column that we're going to use to answer a question. And again, the first that we need to identify how many questions, right? N equal to 5. So we need to go for n first. So the n equal to 5 will be right there. Okay, so n equal to 5. So I'm going to go to the first column, and it's on a chart, and then we can see them that for n equal to 5, you have to go all the way down until we see the 5 right there. So 2, 3, 4, 5. So this will be the box for n equal to 5. Okay, so it's really important. This is the first step that we have to do for the binomial. First, we need to identify the n. If we cannot identify the number of boxes, like the correct box, you're gonna get the wrong answers. Okay, so n equal to 5 will be the first thing that we need to do. The second that we need to look at the probability of success. Usually this number is given, but for our example, I did not give you anything. I just only give you like 4 possible choices, A, B, C, D. So we gotta figure out like the chance of getting the correct answer is 0.25. So now we're gonna look at the the chart on the P right there. So on top of that, so this is 0.25, right? This is P equal to 0.25. So we can utilize this um, to do the questions, right? So identify the column. So this one would be the step number 2. Okay, step 2. The first step that we're going to look at the end, a second step that we're going to look at the P so that we can identify the column correctly. Okay, so the column that we're looking for in this case will be that one. Right, so the column that we have will be on 0.25 on n equal to 5. So this will be the thing that we're looking for. Okay, so this will be the column. Okay, does it work? So we want to ace on the quiz. What does it mean by we want to ace on the quiz? So this is the column that we have to look at. So we want to ace on the quiz, meaning that all the questions have to be correct, have to be answers correctly. So R equal to 5. Okay, so the number of R would be the number of success. In this case, so I need 5 correct answers. I need all 5 of them. So then we need to go to the that ones, and then we go to the second column for this, right? So we can literally check the second column will be the R. So 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4, 5. So we can only have at most 5 correct answers in this case. So the R equal to 5, and then you can literally check them. What we have.
So the R is just the column, like
The second column. So this will be the step number 3. The R should be given from the questions. Let's say this question, I want to ace on the quiz. So I want to have all 5 questions answers correctly. So this one is step number 3, and R equal to 5, right? So then you can't see them. So what is the R equal to 0? Meaning that we get all 5 wrong questions. Like there's no correct answer that we can have on the quiz. That will be 23.7%. What is the R equal to 1? Meaning that I only answers 1 questions correctly. So that would be 0.396. And what is the R equal to 2? So that would be answers 2 questions correctly. So that would be 0.264. And so on and so forth, correct? So what happened if they want to ace in the quiz, meaning that I want to have like 5 correct answers, 5 correct answers, correct? And the R equal to 5, and then you can literally check them. This is the box that we have to look at, correct? So this is the thing. So you take the column and then the intersections of the R, and then the box will be equal to 0.01, which is right there. Right? You can literally check that it's actually equal to 0.001. And when we look back to the nodes that we did earlier, that we computed using mathematical equation like all of these 0.25, and then we finally end up getting the answers, which is 0.001, which is not quite easy. If we just get on the chart and read the number, you can get the answers pretty much immediately, like in a few seconds, right? So we can get the answer, which is 0.001. That's it. All right, so now let's go to the part B questions and see how it turns out to be. So now I would like to look for the probability of, what is the probability of that we can get 4 out of 5 correct answers, sorry, 4 out of 5 correct answers, right? So I want to have 4 out of 5. In this case, that we're gonna go for P, P of R equal to 4, okay? P of R equal to 4. Then we just redo that, P of R equal to 4, right? So I don't need all 5, I just want to pass the class. This is what we just did earlier. And I just want to read it on a chart. And of course, that in this case, we're not going to do any math for this, right? So we have to read those. So how can we read that? So we're going to go to R equal to 4. So 0, 1, 2, 3, 4. So this will be the thing that we have to look at. So the answer for that is 0.015. Are we good?
so
Yeah.
P the right there what you did, the R equals to 4. That's the number of classes that
No, no,
we
no.
I mean
That
of
is the
answers.
number of questions that we answers
Yeah,
correctly. That
yeah,
is
yeah.
the number of success. And so I only need 4 out of 5 answers correctly. So the change that we can have in this case will be equal to what we can read on the chart is 0.015. Are we good? So when we compare to the number that we have earlier, like when we do all of these math and we get 0.0146, and then we end up getting like 0.015, this is like a quite complicated method that we use. And of course, we have to deal with that number using hand and all of the mathematical equations. It took long to do so. But on the exams, I only require us to be able to read on a chart. So let's say I want to answer like 5 correct answers. So we're going to go for R equal to 5. If we want to get like 4 correct answers, then we have to go to R equal to 4. And sometimes we need to add them up, and this is a thing that we have to deal with for chapter 6. All right, so, and we also have to deal with like the standard deviation and the expected value. So what is the standard deviations and what is the expected values? This will be a little bit, what is the expected values? Basically what we call the average, but the average or the mean in this case, all right? So there will be like a number of way of saying, sometimes people call mean or expected number or expected value. So all of that, it will be something that we see on the exams. And it's really important that we, or expectation, another word for that. So this basically means that we want to predict what is, on average, the number of questions that we answers correctly, given by the scenario. So the expected value, if we can find on the formula sheet, which is on chapter 6, um, on the last 2 rows, so we can see that the mean that we have will be equal to n times p. Okay, so the mean, which is called a mean, equal to n times p. N times p, right? So we gotta do that. It's really important. And then the second thing that we need to solve will be called the standard deviations. And we usually use the letter sigma to represent that. If you ask me why people use the letter sigma, because I don't know, I just literally have no idea why people use this symbol. It's just the way that we call sigma. This is one of the Greek letters, and we call this as at the standard deviations STD of X. Okay, and so this is what we call the standard deviations. All right, so that we proving like how scattered of like each questions compare to the question that we have answers correctly. So the standard deviations will be equal to what? The standard deviations will be equal to, so when you look at a formula sheet, it's have to be the radicand of n times p times q. Okay, so we need to multiply 3 numbers and for that. It seems to be really complicated. It's actually not really complicated because we are allowed to use a calculator. Okay, so what is the P? The P in this case is the number of, is the probability of failure. So that will equal to 1 minus Q, I'm sorry, Q will be 1 minus P. I apologize for that. So in this scenario, we have the Q equal to 1 minus P. All right, so that's really important. I feel like that's really important for this. And then we need to understand what it is. So we see it's just proving like how scattered of each data value away from the mean with the corresponding probability. So this will be a thing. Okay, so again, that when we go back to the node, and then we can see that the binomial curve, this is what it looks like. It's going like a bell shape when we have the p equal to 0.5. And this might be looking like this for all of this probability. And it can be screwed left to the right depending on the average. So the average always be the central of the data set. So, and then we can see them, those curves are different because we have different probability for the success. And I actually just did the few question as well. And this is the formulas, or we can also see the formula from chapter 6 on the from the formula sheet, but it's really complicated, right? So sometimes I just put them down like that, and then you can see what it is. So when we come back to the question that we have, and let's say I want to compute, what is the expected number of questions that I can answer correctly? If I give you 5 questions and we have like 4 choices A, B, C, D. So we're gonna go to the part C of the question, right? Part C. And again, I give us like 5 questions, n equal to 5 questions, because we have 5 questions. And then the probability of answers the questions correctly is 0.25. So this is what we have done. The P equal to 0.25, right? Because this is the change that we can answer each questions correctly. So, and now what we need to be doing is that we're going to compute the expected value. So the mean equal to n times the P. We call it the expected values for that. So what is the n? The n equal to 5, and then we multiply by 0.25, and we're going to get the answers correctly. Okay, so I'm going to change the marker a little bit so that you can literally see what we're doing for the work. And then what we need to do, we'll take 5 times 0.25. So that will be the number of questions on average we can answer correctly on the quiz. So this one is 1.25. So what does that mean? You don't really have to write them down, but it's always important to understand what it means by the expected value. So the 1.25 telling us that on average, right, we should expect two answers, let me just, two answers, uh, one out of more than one questions, more than, to get more than one questions, answers correctly, okay? So that, this is what it means um, for uh, for the expected number, right? So it's 1.25. What does that mean? So on average, if you give me 5 questions, I should be able to get more than 1 correct answers. Okay, so this is what it means by the expected values, right? I don't know. It can be 2 correct answers. It can be 1 correct answer. It can be 3. But on average, we should get around 1 correct answers. All right, so that's really important to know it that way. So the standard deviations, on the other hand, will be given by, will be equal to the radicand of NPQ. So the n that we have equal to 5, and then the p is 0.25, and then we can figure out a q respectively. Um, so so the q that we have will be 1 minus p. Okay, 1 minus p. So what is the p in this case? So the p is 1.25. So I'm going to change the marker a little bit because that's really important. So that would be 1 minus 0.25 equal to 0.75. Will be the change that we can get it wrong. This is the probability of failure. This is what we call the q1 minus p. And then we just do the math for that. So then we're going to take the square root of 5, right? So n equal to 5 times point times 0.25, right? Times 0.75 as well. Why 0.75? Because this is the q that we just found right there. Okay, so we just do the math in this case, and then we just plug that into the calculator. So we're gonna go for like the square root. You're gonna heat the second, and then heat the x squared. We're gonna get the square root, and then you plug in 5 times 0.25 times 0.75. And then you can close parentheses without closing it. And then you hit equal, and the answer for that is 0.968. So that will be the standard deviation for 5 questions. Okay, 0.968. Okay, and again, that's really, it's really important that we're gonna do it that way. And how can we do that? How can we do like the square root for this? You're gonna hit the second. Again, we're gonna hit the second. And then after we hit the second, then we're gonna hit x squared. So we can get the square root on a calculator. Okay, let me just show you again how to do that. Hit the second, and then x squared, and then we're gonna take 5 times 0.25 times 0.75. And then we don't have to close parentheses for that. We just hit equal, and we got the answers, which is 0.968. All right, and then we're going to get this one correctly. All right, so this is what it means by taking the square root of NPQ. We're going to get the standard deviation. This is the standard deviation that we call a sigma, and this is one of the Greek letters. Anyhow, so this is what we have to be working on the second exam and the final exam. You're going to see those questions again. No worry. Those are very, very important questions that we need to utilize it and practice as much as you can. So let's go over like questions, and then after that we just want to know what that is, right? So just take a look at the question for that. I assume that we're gonna go for question number 3 on the practice problem that I uploaded in Blackboard. So let's go for it. And this is what the question looks like. Assuming that for a marketing firm, that they found that there will be 50% of $10 coupon delivered by mail and redeemed. Okay, so the coupon, it's only 50% of people getting it, and only 50% chance of doing it. So in other words, we're going to pick 8 people, right? So the thing that we need to highlight for this kind of questions is the P. So we're going to highlight the P in this case. So let me just do that. So we're going to highlight that and see what it is. So so for this, the P equal to 0.15. I'm going to put them there with this marker. Okay. And then after that, we're going to look at the number of customer that we selected. So let's say
P will always be the percentage that they
absolutely
on the question. Yeah. Okay, thank
absolutely. Yeah, P always be on the percentage. Whenever you see the P on the percentage and the N always be the whole number, why it is whole, we can't have like 7.5 customer. That make no sense. In this case, we have the N equal to 8. Remember, the P always in terms of percentage, and then the N always in terms of the whole number. So all we need to remember that. It's really important. Sometimes it doesn't give us percentage, so, but we need to consider it can be percentage or it can be the decimal. Okay, sometimes it gives us a decimal, and sometimes, but most likely the majority of the questions going to give a percentage for that. Okay, so I feel like that's really important. And for the N equal to 8 in this case, so 8 will be A will be what? A will be the whole number, right? It has to be the whole number. You cannot get like something not the whole number for the N. Okay, so it can be. It should be like start from 2, like 3, 4, 5, 6, 7, 8, 9, 10, 11, so on and so forth. And then now we're gonna go to the chart. We have to go to the chart for that. So the first step is we need to go to table number 2, right? And then we have to go to the chart like N equal to 2, 3, 4, 5, 6, and 7. So if you ask me, should we? I don't see A right there. I don't see A on table number 2. So remember, table 2 has 4 charts. You have to flip your pages, go to the next one. There are actually 4 of them, right? So 8, 9, and then 10, and then 11, 12, 15, and then 16 and 20. So remember that all of these values that we're going to learn and use on the exam and the final exam, that's really important. So this is for the N equal to 8. How do I know that? Well, I mean, I can look at this, right? So the N have to be on the first column. I can see that this is 8, 9, 10, but we need to pick N equal to 8. We cannot go for N equal to 9. So that will be the first thing that we need to do first. That we're going to, okay, of course I have to like copy and paste on the chart first, right? And this is the thing that we have to look at for N equal to 8. Okay. All right, so I'm going to copy that and post this here. Yeah, this is the chart. This is a very important chart that we're going to use it. All right. Okay, so let's go for it. All right. So remember that we only have at most 8 customers, and so but you need to add something, subtract some, add something in this case. So for the problem, so we need to highlight that the n equal to 8 right there. So apparently that we're going to go to n equal to 8, right? So this is the n. This is the first step. We look for the number, the value that n equal to 8 right there. And then the second thing that we need to look at will be the p equal to 0.15. So this is the p, right? So the p will be on the first row, right? So n are 0.01, 0.05, 0.1, and 0.15. So remember, the percentage will be 50%. You need to convert to the decimal by taking 15 over 100, and then we got 0.15. And then we need to utilize this chart, this column, to answer the question, to answer the part A and part B questions. Are we good? Right. So remember, we take the intersections between on that column and the box. So this will be the column that we have to use for our questions. So now let's go answer this question real quick. And part A, what is the probability that no more than one? So we need to answer like probability of no more than one, right? So what does it mean by no more than one? What does that mean by no more than one? Everybody?
Only one answer.
No more than one customers, no more than one customer. So for instance, like no more than two, for instance. So what does that mean? So more than one is greater than one, right? Like two or more. So no more than one in this case is one or less, one and none, correct? So we need to add of for p equal to 0, r equal to 0, and r equal to 1. So we need to add up the first two numbers that we have seen on the column. So let me just repeat that again. This one will be a very important keyword that there's so many of us who answers wrong on the exam. So we got to be really careful. So no more than one, meaning that one or less, or one or fewer, or 1 or 0. Okay, it's important. So no more than two, what does that mean? So that would be 2 or fewer. So no more than 3, so that would be 3 or fewer. Okay, so in this case, so no more than one, meaning that we're going to add of like 0 for r equal to 0 and r equal to 1 together. So I'm going to box this, right? I'm going to box these two. That's really important, right? So we're going to add up these two numbers for part A. Okay, so I'm going to box that one. So this one is part A questions, right? So we need to count 0 and 1 in this case. And the answer for that will be 0.272 plus 0.385. So remember, the chart is filed on the informations or on the math department website. So making sure you have to read the chart to do the questions correctly. So we're going to 0.385, and the answer for that is 0.657. Okay, so this will be the answers for part 8. That's it. And all we need to do, just figure out the keyword and understand what the question is asking you to do. And very important that we need to use the right column to answer the questions correctly. And similarly for part B, let's go for part B questions. I want to find a probability that at least 2. So let me just highlight the keyword for that. It's really important. No more than 1 means 1 or less. At least 2, what does that mean? At least 2. I want you to figure out a
Two
problem.
or more.
Exactly, right? 2 or more, because at least mean the minimum number is 2. So at least 2 in this case, that would be 2 or more. So we're going to add it from 2, 3, 4, 5, 6, 7, 8, right? 2, 3, 4, 5, 6, and 7, and 8. We're going to add them up together. And that's also the final answer for that. Okay, so we're going to just add of all of these values from 2 to 8, right? So we're going to add them up like that. So from 2 to 8, and we're gonna get it done. So let me just use different markers so we can see through what the part B looks like. So this is part B. So we're gonna add up like the probably from 2, 3, 4, 5, 6, 7 up to 8, right? So let me just repeat that again. At least 2, meaning that 2 or more. The minimum value is 2. Okay, so it's really important that we understand it that way. Okay, so let me just do that. The least mean minimum, okay? Most, at most, mean maximum number. So let's say I ask you a question, at most 2, so that will basically like 2 or fewer or 2 or less. So it's always important that we have those keywords understood before the exam. So we're gonna add them up like p equal to 2 to p equal to 8. So apparently p equal to 2 that we got the answers, which is 0.238 plus p equal to 3 equal to 0.084 plus 0.018 plus 0.003. But for r equal to 6, you're going to get always 0. So just add 0 plus 0 plus 0. It just put 0 right there, and then I understand it. And now we just add them up, all of these values, and we're going to get the final answers correctly. So this one will be equal to what? So we're going to add them up like 0.238 plus 0.084 plus 0.018 plus 0.003. So for that questions, we got the answer, which is 0.343. Are we good? We'll just add them up. So remember the total. So some of you might be doing something really fun. So instead of I just add up these 5 or 6 different values for that, I can just, because each column total probably have to add up to 100%, right? Instead of doing that, I can also take 1 minus the first 2. So the first 2 that we add them up for part A, that was 0.657. And basically we got the same answers, which is 0.343. This is also a shortcut that we need to do. We can do on the exam, but not necessarily important. The most important thing that we need to do with that for these questions is to add up the correct number, identify the keyword, and then see which part of it that we have to start adding, which part of it that you have to end. So that's really important. So let's say at least 2. So you have to start adding from 2 all the way up to 8 customers. So we cannot have more than 8 customers because we only pick 8 of them, right? So we only use the column for n equal to 8 and then p equal to 0.15. So that being said, we can figure out the standard deviations and the average. So the mean that we have will be n times p. Why is that? Because we have this formula before. We have these forms. We just literally just box them right there. It's really important that we box this because this is the form that we have to use on a second exam and the final exam. I guarantee you, like 100%. So the n and p have to be the number that we found at the very beginning of the question. So in this case, the n equal to a customers, so that would be a, and then we multiply by p is 0.15. Remember, we're going to use these 2 numbers to compute this math. Okay, so let me just box them. We just want to make sure that we use those 2 numbers at the very beginning of the question. We're going to take 8 times 0.15, and we're going to get 1.2. What does that mean? That means if I pick 8 people by random, I will have more than 1 person who got the coupon delivered and redeemed. So that's really important. That will be a thing. So the n and p have to be the thing that we're going to use at the very beginning of the question to answer it. So the standard deviations on the other hand, so this one we can also use this letter. I don't quite like using all of the Greek letters generally, but those are sometimes really important. This is represent this the mean, and this represent the standard deviation. So the standard deviation that we call STD, right? STD. Okay, and why we call STD with just for shortcut for that. And the standard deviation that we know, what is the form for that? The formula that we have learned it, we have recognized it. We haven't really proved anything for that. So we recognize which is radical NPQ. Okay, so we're going to take the radical of n, times P times Q. Okay, so that's really important that we're gonna figure this out. So the n in this case equal to what? The n that we have is 8, right? You're gonna plug in the values. So I want to use a different marker for that. Just want to make sure that we get it done. 8 times the p. What is the p? We're using a SAM p, which is 0.15. And then we multiply by, what is the gain?
Hold on.
Yeah. All right.
I don't know.
All right. So let me just hold on a second. So let me just finish that, and then so the key that we have equal to 1 minus p. Okay, 1 minus p. All right, in this case. So what is the 1 minus p? So the 1 will be this is the chain that the customer do not redeem the coupon. So 1 minus 0.15, and we got
0.85.
0.85, and then we multiply this
I was
by
gonna
5.
ask you that. How we find the Q?
Just take 1 minus 5. It's simple. So we have 50% people who redeem the coupon, right? So what is the percent of people who do not redeem the coupon? Correct? So there should be 0.85, right? So let's say the chance that people go to eat out today is 60%. The chance that people stay home and do not go out to eat out, that'll be 40%. So this is the thing that we can think of it. So we take 1 minus 0.15, and we're going to get it done. So after that, we're going to take the square root and then go to 8 times 0.15 times 0.85. You don't have to close parentheses for that if you want. You can close it. So the answer for that will be 1. On average, like we should be having 1 customer who do not redeem the coupon and 1 do redeem the coupon on average generally. Okay, so that'd be 1 customer for that. Anyhow, so this will be the mean and standard deviation. Of course, we're going to go over all these questions again next Monday, and that will be very, very, very important. So again, that the exam grade was on Blackboard. If you couldn't really find a grade, because if you submit it on by email, for instance, that the browser closed out before whatever, for some reason, I checked the time, it worked, and it might take me a little longer for that. So I will be in the office hours. So how can you go to the office hour? You can click on this link. I'll be there, okay? And then grading all of you guys who submitted by email or some issue for that, and I will give you the grade. You can, go there and check them with me, okay? I got a couple of emails saying that we don't have the grade in Blackboard, but because of the fact that we did not submit it, the work properly, and sometimes takes a little bit longer to do it. Okay, Shayla is here. Shayla. Vanessa is here, right?
Yeah. Yeah, I'm here.
Permanda is here. Okay, Rena.
Yes.
Okay, Ulis. Okay, Afri. Diego. Again, that I'm going to post the midterm grade on Blackboard. It doesn't mean anything. It's just like it's having fun. It's not going to be something that determines the final grade. The final grade would be the official grade uploaded on the CUNY first, but the midterm will be on OSIS. Or you can double check them. It doesn't mean anything. It's better than nothing. Diego's here. Jose's. I think his name is John, but Adama is here.
Yeah.
Very good, sir. And Jesper is here for sure. Eric. Arlene is here.
Here.
Emily is here.
Yo, I'm trying to.
All right.
Here.
Okay, so Katrina is here, right? I do it. Okay, very good. Virgin is here.
Yeah.
Nia.
Yeah, I'm here.
Anir. So did you send me the file of the exam? Please do so. I'm gonna check them. If you can show me the date and then the time that you got the file, Out of that, I'm gonna count your second exam twice. So just let me know what you think. Okay, just email me again.
Okay.
All right. So yeah, I got you, Emily. So you'll be there. I usually look at it. For those of you who got the grade, and so I will post the homework assignment under assessment right there, and you're gonna start working on a homework problem for today. Richard is here.
We got a homework.
I'm here.
Yes, we'll have homework, but that will be due next Wednesday because we
Oh,
only
next
have
Wednesday.
one questions. We can't finish the homework. We need to do more practice for that. Joel's is here. Joel's. Otis. Kimberly is here. Kimberly.
Yes, I'm here. I'm here.
All right, Janik.
I'm here.
Okay, Janik. So your situation's gonna be the same because you did not upload a file on Blackboard. Just remind me again before the second exam. I want to count the second exam twice. Okay.
Okay.
All right, Steven is here. Steven. Selena. Selena. Remus. I got
I'm
you.
here.
Yeah. Jason's is here. Jason. All right. So Jason's actually did. Yeah, and email me saying that he was busy or something like that. Rob is here, right? Robert.
I'm here.
Amber. Amber is here. Yeah. And Melinda. Melinda, I'm gonna grade your exam real quick if you can wait for me like during the office hours. So that'd be great. People submit it. And Jodali is here.
Yes, I'm here.
Very good. Brian Burris is here. Oliver is here. All right. And Oliver, did you file your grade yet?
Yes, I saw it. I told you earlier because you know how it was two, like one you submit the work and the other one you just look
Okay.
at
So,
the.
but did you
Yeah.
get the grade on Blackboard or not?
Yeah, I saw the grade on the one that says
All
work
right.
here.
Okay.
That was the one, right?
Yeah, that
All
was
right,
the
thank
thing
you.
that I graded. All right. So you guys going to have a wonderful weekend, and we're gonna see each other again on Monday. And make sure after that we're gonna have a quiz on Wednesday. So make sure that we show up on Monday and just do the work and so on. So I'm gonna give a lot of practice questions. So remember the practice questions on Blackboard. Come up with the solution on it, and please try to practice all of this right after that. All right, and after Monday, but not today, right? So I'm gonna upload the homework soon, but it will be due next Wednesday as well. You guys going to have a great weekend, and take care.